Bismillahirrahmanirrahim. So this is the first part of the fifth lecture of statistics and probability theory. In previous lecture, we have discussed the measure of central tendency. Measure of central tendency is a single value which represents the whole data set, and usually we have three measure of central tendency: mean, median, and mode. Most commonly used measure of central tendency, and basically there are five type of averages: mean, median, and mode, geometric mean, and harmonic mean. We have discussed mean, which is arithmetic mean, median, and mode for group and ungrouped data in previous lecture. Today we will discuss the properties of arithmetic mean. Properties of arithmetic mean. The very first property is, for a set of data, the sum of deviations of the observations xi's from their mean, which we represent it by x bar, as we are representing the observations as xi's, taken with their proper signs, is equal to 0. So what they are saying, that if there are some observations xi's and they have mean x bar, and the sum of the deviations of the observations from their mean. Deviation means that you subtract each observation with its mean, and then you sum all the values with their proper signs, either they are negative signs or positive signs. Answer would be always 0. Whenever you subtract each observation from its mean, that is, you take the deviations and then you take a sum all over those deviations, the answer will always equal to 0, because mean is the measure of central tendency. This is the arithmetic mean, and this is usually the midpoint of the data, or the point of the data in which all the values of the data realize. So when you take the deviations and you subtract them and sum them, the answer will be equal to 0. So this could be like this: summation xi minus x bar. We can prove this mathematically also. That is, by equating it, we are taking the summation sign inside the bracket. So it will be summation xi minus summation x bar. So this x bar is basically a constant, because this is a single value and sum always apply to the variable. So this would be equal to summation xi minus, this would be x bar, and this would be summation, and it will be equal to 1, because we have taken the x bar before the summation sign. So what would be the summation 1? And the sum is from 1 to n. So this is also I is equal to 1 to n. So this is the situation. Now what we will do with this term? As you can see that this is summation I is equal to 1 to n xi. So we can make it x bar if we have n in the divisor, because we know that x bar is equal to summation x over n. So what we will do, we simply divide this with n and also multiply this with n. That is, we are multiplying and dividing this term with same constant, which is small n. Now what we have, if you concentrate on this term, this particular term, this is x bar. So what will be next? This will be n into x bar minus x bar into summation I is equal to 1 to n, and this sum is applying over the constant 1. So what we will do with this particular term? So as we know that whenever we apply the summation, it means that we are summing that particular number, or if it is a variable, we will add all the numbers coming in the range of that variable. That is, this is xi, I is equal to 1 to n. This means that this variable x contains n observations or n values, and when we apply this summation on this, it means we are summing over n values. But now this is a constant, this is not a variable, and it means this is not changing from term to term. So what we will do, summation I is equal to 1 to n into 1 means we are adding this 1 n times. It means 1 plus 1 up to so on. We will add it till the number of times n, but it will remain the same as n, 1 is a constant. So if we say that, let us suppose that n is equal to 2. So I is equal to 1 to 2, and we are applying this summation on 1. So what does it mean? It will be equal to, we are adding 1 plus 1, which will be equal to 2. If we say that I is equal to 1 to 4 and this sum is applied over 1, so it means that it will be equal to 1 plus 1 plus 1 plus 1 is equal to 4. That means we are adding 1 4 times. So here we come to know that summation I is equal to 1 to n, and this summation is applied over 1. It means we are adding 1 n times. So this would be equal to n. So what we will have now, this would be equal to n into x bar minus x bar, and this particular term will become n, as we have shown it here. So this would be equal to n. So this will be n into x bar minus n into x bar. We can write it this in this way, and definitely this would be equal to 0. So mathematically we have proved that summation xi minus x bar will equal to 0 always. You can prove this through by numerically also, by taking some observations and by finding their mean, and then by summing over them all the deviations, the answer would definitely equal to 0.